Oh, I gotta find an expert. Should I buy this thing? Oh man, let's talk to an expert. Who is this guy? Need to buy a bike today. Oh my god, I gotta buy a new. Oh, yes. Dag. Just kidding, folks. Welcome to the Daily Space Weather. Check the links below the video if you're in the market for a bike or even an upgrade. I'll consider helping you shop. Drop me a line. Here's the sun. Welcome to the Daily Space Weather video. That's 2 days worth of solar activity. We've got a massive uptick in things like the radio flux and the sunspot number. Also a large plage, not to be confused with large marge, up in the northern hemisphere, right up here. And a bit of a solar smiley face once again. You've got this sort of a thing going on here. Am I right? Take a look at this sunspot group and another group forming right in front of it here. So we've got, again, a major uptick in activity. Likelihood of large solar flares way up. Radio flux up to 94. We'll get to that in a moment. Here's 94 angstroms. And here's 131. You can see this active new sunspot group forming ahead of this 2898 group. So that's 2899 right there, I think it'll be. And we'll cool out the beginning of the video portion of the sun with, there you go, 335 angstroms. Again, the radio flux up to 94. So a sudden uptick in the radio flux there. Basically what you would expect as solar activity ramps up into cycle 25. That's a 1-year chart from Solon.info. Space Weather Enthusiast dashboard indicating some geomagnetic unrest forecasted late in the day tomorrow, the 27th, and early in the day on the 28th from a coronal hole wind stream. We'll get to the coronal hole later. First, seismicity. There's an earthquake drought going on, and we've seen an uptick since yesterday. These could be foreshocks, so be on the lookout. Be prepared for buildings to start falling down if you're in a place with ones that are not earthquake safe. This is 2016, and 2016 was a fairly consistent year, not with a lot of earthquake droughts. 2017 had a very long drought between February and July. 2018 had a very long drought of 7 magnitude earthquakes between March and August. There's 2019. There's 2020. Anyway, here is the past 90 days, and you can see we are currently in a 7 magnitude earthquake drought. A little bit of an uptick from yesterday here. An additional 6.0 magnitude earthquake at the Solomon Islands. So more activity there northeast of Australia. Very deep quake at Fiji. Over 615 kilometers estimated depth there for that 4.4 magnitude quake. The deep quake capital of the world, the area by Fiji and Samoa. Largest quake of the past 24 was the 6.2 at Myanmar. Again, keep in mind, folks, that could be a foreshock. So again, be prepared while earthquake droughts are going on. Be prepared in general, of course. And I won't get into the reasons to be prepared. Hey, how about, do you have a bike in your prepping supplies? If not, drop me a line. Links to my curated page below the video. I will help you shop for a bike. And if you're a new rider, I'll be building a cyclist. So there's a deep quake at Vanuatu. That one's at 520 kilometers estimated depth there. That 5.8 would be like a 7 magnitude quake if it happened at the surface. That is sufficient to cause a tsunami. That is in a tsunami generating type zone. 5.7 at the Japan region. So a little uptick there. But the 7 magnitude earthquake drought continues. Regarding volcanoes, we're very interested in geophysics because the Earth-Sun space environment and so on has an effect on geophysics. So let's check out the list of volcanoes. La Palma, still erupting, we'll assume. No indication of the size of the ash plume from La Palma. Subodose-jima, flight level 060. Semeru, flight level 140. It's exploding on East Java. Fuego also exploding. That's in Guatemala, 15,000-foot ash plume on Guatemala. Nevado del Ruiz exploding, flight level 190. 19,000-foot plume of ash from Nevado del Ruiz. Sangay, 20,000-foot ash plume as Sangay explodes. That's in Ecuador. Revenador, also in Ecuador. 15,000-foot ash plume as Revenador explodes. Sabancaya, no indication if it's erupting or not. Don't pole vault the caldera. Don't become part of a lava lake. Nevados de Chilean is exploding. Flight level 140. It's a 14,000-foot ash plume over central Chile. Don't forget to enter the promo code CYBER5. Links below the video to the Red Bubble Shop. They're in order of best selling, and today's featured product is Mensa. Make Earth Not Suck Again. The design comes on all kinds of different things. Everything from coasters to prints to t-shirts, even leggings. Today I'm wearing the hat. Mensa, Make Earth Not Suck Again. It's completely apolitical. If you have any kind of derangement syndrome, we hope you get better soon. Mensa, Make Earth Not Suck Again. It's up to you, not giant, ineffective bureaucracies that do more harm than good. Remember, folks, if the cure is worse than the disease, you don't apply the cure. You can find links to that at the homepage as well, smashomash.com. Come visit it. Smasho Forum. Smash Team. Thanks to Smash Team members. Thanks to our paid subscribers, especially at Smash Team. Smashomash.com/Smash Team. We replaced Patreon with something vastly superior. Smashomash.com/Smash Team. Here comes magnetic data. And there's the GOES magnetometer over the past 3 days. Pretty smooth here. Earth is in a North Pole current sheet. And we can expect to stay there for the foreseeable future, as the only sunspots we see are in the southern hemisphere. There is the line of sight ecliptic plane field plot. We showed you the top view first. Here's a coronal hole line of sight plot. Trans-equatorial North Pole oriented coronal holes rotating in here. That is a serious coronal hole there. And it's probably going to look more and more defined as it gets physically closer to planet Earth. So here it is in 193 angstroms. Great view here of these coronal holes. Big plage right here behind them. And you can see some filamentary collapse activity happening right around here. That did not generate any Earth-facing coronal mass ejections. Likelihood of solar flares is higher. We're going to go to a coronal mass ejection watch for the Earth side of the sun. And it's because of the sudden formation of this sunspot and the sudden... Well, 2898's been stable. I won't say it's suddenly grown. 2898, similar to yesterday, really. But this new sunspot does make a difference. And some umbra have appeared here over on the western limb as well. (2898) is the most likely place for major solar flares. It's a beta-class sunspot, and it's quite large. It's got complex umbrae of opposite magnetic fields. Little bit of flaring happening here. Again, likelihood of large flares much higher with those new sunspots in the south. No proton flux spikes. No surprises there. Real-time solar wind looking like. Seeing an uptick here in the density. But it's pretty minor. Remaining under 10 protons per cubic centimeter. It's only at about 7. Solar wind speed quite slow here at 350 kilometers per second. KP index at 1. over the past 24 hours. Past 27 hours, actually. Next, magnetohydrodynamic pressure over the past 4 hours. Note the time and date stamps. And it should look pretty homogeneous here. Most of the pressure would be in the magnetotail side with that slow and moderately diffuse solar wind. A little reduction in the overall pressure there. Next, we looked at the magnetic moment in space. Here's the magnetic moment on the ground. Ground magnetic perturbations changes to Earth's B field. Geospace delta B. Excuse me. And nothing too exciting happening there. This will show you where auroras are during periods of geomagnetic unrest and storm. Next, a solar system forecast. Here's where things are now. There's where things will be in a week, approaching another new moon. Leave us a comment if you, too, are a reverse werewolf. Let me draw in the ecliptic and the galactic plane here. That's better. And that's what's going on above my head here in Lehigh Valley. We've got the moon there. The ecliptic is the yellow line. That's the path the sun will take across the sky. Here's the blue line. That's the galactic plane. Let's move on. 2, look at our coronal mass ejection watch here from stereo A and Lagrange point 1 at the LASCO. Oh, no, wait. It's just stereo A we're looking at today. So we're going to look at stereo A, coronagraph, and the difference imagery because we had another far side coronal mass ejection. So Earth would be off in this way, in this direction here on both images. And the difference imagery is earlier imagery subtracted from the current imagery to give you additional contrast, basically. So stereo A's coronagraph here on the left, the raw data, and the difference imagery here on the right. See additional non-Earth side of the sun coronal mass ejections. And let's blast through cosmology. Today's random number is 511. And at the Neil Gehrels Swift-Bat X-ray Observatory, that coincides with something. It's a pulsar. And a pulsar wind nebula, so that's great. How about that? PSR B1509-58. That's our, quote, random and, quote, object. Here are its X-ray outputs, and it looks like a pretty weak X-ray emitter there. It's in a very tight range, probably very far away. Let's take a look at it on the CDS portal. So here's an X-ray survey. This is 2 to 4.5 kilo electron volt X-rays rather. And this is quite a violent looking system here. This Pulsar wind nebula. A lot of activity happening there. A lot of things emitting X-rays. You can see that signal there. Quite complex. Let's look at some other bands. And here's the XMM Newton, and this is absolutely spectacular data here. This Pulsar wind nebula. It's got quite an irregular shape to it. It looks like a miniature galaxy in a lot of ways. As that is all X-ray emissions, folks. Interestingly, in this ultraviolet survey, it is basically a dark part of space. It's probably, this object is sort of probably the main source of mass there. But in any case, let's go to optical. So here's a 2-year survey in optical. And you can see that the crosshair is sort of on that bright area there. That's pretty interesting there. Again, we're looking at the Pulsar wind nebula, not just the pulsar. And here's how busy it looks in infrared wavelengths. Pretty busy part of space here. And quite dark in infrared frequencies. So it's kind of cold and kind of bright in X-ray. And indeed, a quick look at the photometric points here. You can see indeed that it's got dark portions of the electromagnetic spectrum. And we'll just quickly show one radio image here. This is 1.4 gigahertz. And since this is close to the galactic plane, as you can see there, it's quite a bright radio spot there. and quite a large radio spot. It's almost like a miniature galaxy in a lot of ways with as much X-ray emission as it has. And we'll go back to X-ray here on the Chandra. The very high resolution X-ray imagery there from the Chandra. You can see all those sort of filamentary features there in that Pulsar Wind Nebula. It's giving you some idea as to the jet. It looks like the jet is sort of oriented partially toward us and partially away from us. You can see some idea of likely motion happening there with all that detail from the Chandra. Again, it looks like a little kind of like a miniature galaxy there within the Milky Way galaxy. Very interesting object there, number 511 on the Neil Gehrels Swift-Bat X-ray Observatory, Pulsar B 1509-58. And you can find links to that if you like. Again, it's entry number 511 at the Neil Gehrels Swift Observatory. Check out the astronomy picture of the day. It's pretty sweet. Once again, the Pleiades and a lunar eclipse showing up. So there you go. There's the Seven Sisters and the Lick Observatory, the Lick Telescope. apod.nasa.gov. If you want to check that out yourself, that's today's cosmology segment. Check our playlists for more. YouTube.com/smAsho/playlists. The daily space weather videos are currently exclusive. Congratulations on realizing they exist. Good luck finding them on YouTube. They're public. They've been public for years. Let's take a look at surface charging. We ain't got none. Let's take a look at internal charging. Ain't got none of that either. Right? Relativistic electrons can cause surface charging. Here's a 1-year chart of the relativistic electrons. And we're not at warning levels. We're just sort of at moderate levels. Here is the 3-day chart. Briefly got into warning levels for only one of the satellites there. So the GOES 17 got into warning levels, but not the GOES 16, indicating, different amount of electron flux measured below those satellites. They measure it at the Ionosphere layer. We'll show you imagery of that later in the video. Here's the forecast for relativistic electrons, expecting them pretty consistent here. I would say they're going to be a little bit lower at the trough, but it should be close to that. No complaints about the NOAA model there. Next, the total electron content forecast. Sorry if the video's not controversial enough. Here are the most likely spots for GPS errors. Your GPS satellite has to communicate through a lot of electrons. And this is the model attempting to show you where those electrons are likely to be. A lot of measurements are happening as we speak. And anyway, nothing too crazy going on with the total electron content forecast. Next, the ionosphere. We're going to show you the F layer. Here's the ionogram. Vibrational frequency in megahertz, millions of vibrations per second. There's a lot of vibrating going on above your head, especially around the equator at noon. And there are some anomalies happening in the ionosphere once again. They always are, and they're most often centered over the South Atlantic anomaly, which is now over the South American continent. And let's bring up the anomalygram. There's the anomalygram showing high frequency in blue, low frequency in red. It's anomaly in megahertz from the 30-day median. So some high frequency ones happening there in the southern Indian Ocean. High frequency ones in the West Pacific, as well as wild swings of high to low, low to high, and so on. Here's the latest image, 9:45 Universal Time, Ionogram, 9:45 Universal Time, Anomalygram, mostly low frequency at that moment. We've got bonus features, starting out with the ground-based observatory at Udaipur, India. You can see some filaments down here. Again, there is a coronal mass ejection watch on the Earth-facing side of the solar disk. Likelihood of solar flares much higher. It's a solar flare watch and a CME watch and an earthquake drought all going on at the same time. Here's your latest intensitygram. We'll press refresh so you can see it get refreshed, so you know we've showed you the most recent imagery. So check it out. We've got this new sunspot here formed in front of sunspot 2898. That's going to be 2899. It looks like it's beta class already. We'll look at the fields here in a minute. First, your zoom out. And some new sunspots growing there too. So that might be 2890, 2899, 2900. The names really ultimately don't matter, folks, but there are the fields. That's beta class, that's beta class, that's beta class, and that's beta class. So we're going to have a massive uptick in the sunspot number here. Here come close-ups. So this is the most significant sunspot, the most likely place to see major flares. It's pretty big. Here's a full disk view. You can see some filamentary collapse happening up here once again. No Earth-facing coronal mass ejections yet, not ones even that are in the Earth vicinity. Just some collapses, and notice how we haven't been forecasting CMEs around Earth. Next, 171 angstroms. And that's where we'll have to end the video. Thanks for tuning in. Please visit the links below the video. And may that solar wind be at your back. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted, name and news.